This is video 40 in the lectures on the design of reinforced concrete beams. This lecture deals with pre-stressed concrete and introduction. First, we will talk about what is pre-stressed concrete and how do you achieve it. Then we will tell something about the pre-stressing reinforcement and the systems. We will learn something about the calculation in serviceability limit state and in the ultimate limit state. And we will end with 6 examples of how to design beams with pre-stressed concrete. The definition of pre-stressing a concrete element: it is generating internal stresses, making it more resistant to withstand later imposed loads. The problem is that cracked concrete does not contribute much to the bearing capacity. In fact, none. Cracked concrete is bad for the durability because of the ingress of water and chemicals. So the best thing is to keep concrete under pressure, and you can do that by an imposed load. This is pre-stressing. Suppose a stress diagram under loads, on top the compressive stress, on bottom the tensile stress. We apply a centric pre-stressing force to the section, compression everywhere. So when we end up with a compressive stress in the whole section. The disadvantage, of course, is that on top you end up with a large concrete compressive stress. You can make it better by using an eccentric pre-stressing system. This is the stress diagram under the loads. This is the stress diagram under the pre-stress, and you end up with a neutral section. Of course, the disadvantage is that under the loads, you will, which are varying, these are mobile loads, so the tensile stress will appear now and then, top or bottom, so there is no reserve in that tension zone. And finally, you can have the stress diagram for the loads, and you add the stress diagram for the pre-stressing force, but the pre-stressing force is there with a varying eccentricity. So according where it is needed, you can have more or less compression. And it makes that at the end, in the overall section, there will be compression everywhere. To explain this a little bit better, if you have an isostatic beam, you have centric pre-stressing, then you will see in the middle that you will have compression, and you will have at the top fiber too much compression. So that's not very economic to do so. You can now use eccentric pre-stressing, then you will see in the middle it will be fine, it will be okay, because you generate stresses which are compensating the actual stresses. But now you will see at the support that you have a very unfavorable situation where there are tension stresses on top because of the pre-stressing present. So what we have to do is we have to change the profile of the tendon in such a way that situations like this are avoided. The advantages of pre-stressed concrete: they avoid cracks because they're all the section is under compression. We can use high quality steel bigger than BE 500. We can use steel up to 1850 megapascal. We have a better resistance to shear force. We know that the normal force acts favorable for the shear resistance. We have less volume of concrete for the same bearing capacity. But there are also disadvantages of pre-stressed concrete. There are pre-stress losses due to shrinkage and creep on short and long term. Those losses can add up to even 200 megapascal. It is an advanced and a specialized technology, and the behavior on the very long term is not known. So that can be a problem, but must not be necessarily a problem. Post-tensioned pre-stressed, we can use systems like the trumpet. The blue one is a trumpet. Then you have a head. In the head there are different cables inserted into that. Each cable consists of a couple of wires. Then you have the sheet. After the trumpet you have the sheet, and the small orange elements are the wedges, that is to block the cable once they are under tension. The typical jacks where you put the tendons under stress. You can also have an external pre-stressing system. It is of course post-tension pre-stressed, which is inside a bridge beam. And here you see also a system of slab with pre-stressing cables. This is again the trumpet or the protection for those cables. Pre-tensioned and pre-stressed, most of the time in the factory. There you have the tendons that are stressed, and afterwards you put on the concrete. The pre-stressed without adhesion, then you have the wires or the cables that they form together one tendon, and they are in a protective layer with some fat into a polyethylene tube. So it's pre-stressing without adhesion. External pre-stressing can also be, for instance, to fortify a bridge. This is these are the beams of the bridge, and you can have external cables which you can put under stress. This is again inside a bridge where you have the cables running freely. So you have pre-stressed concrete, and you have two systems, post-tensioned or pre-tensioned. For post-tensioned, it's expensive because you first have to pour the concrete, then you have to go on site, you have to put the jacks on site, and you have to put the tension into the tendons. So that's expensive. Pre-tensioned is cheaper because it's done in a factory. Post-tensioned is less durable because you work on site. Pre-tensioned, it's in a protected environment, so it's durable. Post-tensioned is, like we said, casted in situ is possible, but pre-tensioned is most of the time it's in a factory, and it's used for prefab situations. You have less pre-stress losses, and you have more pre-stress losses in pre-tensioned. And post-tensioned is okay for large elements, and pre-tensioned is most of the time used for limited sizes because you have to make them in a factory. So now you know what pre-stressed concrete is. See you in next lecture.